9.7 talks about non-homogeneous linear systems. This is very close to what we did before. Given x prime of t equals ax, plus we're adding to it. So this part right here has been what we've been solving in the previous sections. Now we're adding this non-homogeneous part. The solution would be x equaling the complementary plus the particular, where identical to the previous, if f of t happened to be, when I say previous, I'm talking about chapter 3. If this f of t happened to be some t times a vector, we're talking about this function, then the linear, so an example of that, if you see something like 1t, which is the general linear equation, then you would let x equal particular, that is, you'd let it be at plus b. If you recall, that's like saying if you see x, the general rule is ax plus b, right? From back in the days. What's the goal? Find a and b and you're done. It's a bit of work. You're not going to like it much, but it's kind of fun. If I see a sine of t multiplied by g, or if I see a cosine of t multiplied by g, then automatically I would let the particular part be what? Well, obviously, a cosine plus b the sine. And what's the goal? Find a and b. Finding a and b requires you to solve some systems of equations. And if I see an exponential, if f of t happens to be a to the t times g, identical to the prior rules, so then you let x sub p equal e to the at times a plus b e to the a2t, and find a and b. And you'll know what I mean once we get there. So, on top of what we did in the previous section, the complementary is really section 9.5 and 9.6. We just did that. Add to that the particular solution. So the problems are lengthy. We need some room, tons of room. It says use the method of undetermined coefficients to find x prime equal ax plus f of t. Here f of t happen to be what? F of t happens to be -1, -4 times t plus -1, -2. That's like saying ax plus b, right? That's like saying y equal ax plus b, like a linear equation, But these are vectors. So the way it's going to work, we take whatever this is, right? We need to figure out what that is. Well, this right here, I'm going to call this G, and I'm going to call this K. You call them whatever you want. G is this vector, and K is this vector. So, I know that x prime equals ax, in this case, plus t multiplied by g plus k. And in case you're confused, I'm going to color code those until we're done. Now, first, I'm going to say the complementary solution. And the complementary solution, we're going to let x equal u e to the rt. And x prime will be r u e to the rt. And I'll proceed accordingly like we did before. I'm going to get x prime to equal ax, well, x prime is ru e to the rt equals a times u e to the rt, nothing different. And this would mean that 0 equal a u minus ru, and 0 will equal u times a minus ri, or lambda I like to call it lambda. This book sticks with r. And if you say u equals 0, that's trivial. So it must be that a minus ri, and we agreed the determinant of that equals 0 is the way to go. So this part we're not going to show. We're going to jump straight to this to figure out the homogeneous or the complementary solution. The complementary solution, we would say, if I take, and there's a 1 minus lambda, 1 for 1 minus lambda to equal 0. That is 1 minus lambda squared minus 4 equal to 0. 1 minus lambda equal 4. So 1 minus lambda equal plus or minus 2. Swap those. 1 minus plus 2. So lambda equals a negative 1 or a 3. And the traditional, again a bit lengthy, lambda equal 3. We would solve negative 2, 1, 4, 2, 0, 0. And obviously multiply, so the bottom row zeros out. X2 is free, and 2x1 equal x2. So here, if I let x2 1 equal 1, x2 will be 2. E to the 3t. We did that before, nothing new, I'm just reminding you. And if I take lambda equal negative 1, then I'm solving the equation 2, 1, 4, 2, 0, 0 multiplied by a negative 2 and add it. So negative 2 row 1 plus row 2 and row 2. And here I should have said twice row 1. Oh, something's not right. Lambda equal 3. Dang it. 1 minus 3 is negative 2. And 1 minus 3 is negative 2. There you go. If I take twice row 1 plus row 2 and row 2, then that will happen. Here those will zero out. X2 will be free in that case. And 2x1 equal negative x2. So here you have an option. If I let x1 equal negative 1, then that will be a 2. Or 1 negative 2, whatever you want. E to the t, again, any combination of those will work. That would be the homogeneous part. Now, I want to drop the homogeneous to the bottom because this is a bit iffy. Just a bit. And I want to focus on the new part. I want to focus on the particular. The particular is not that simple. In the particular part, we say let x sub p, the particular, be. And do you notice what we have? We're going to say ta plus b, the general for a t. If this wasn't there, I would still do the general for a linear. If it's quadratic, it would have been at squared plus bt plus c. So the general for that. And now I'm just going to plug in. The work is straightforward, but it's lengthy. If I take a derivative of this, why a derivative? Because I want to satisfy that. Wouldn't the derivative simply be vector A? That's it. So, if I substitute that in, this says A equal AX, but we just agreed that X was all of this. TA plus B plus TG plus K. And now what I'm doing, I'm trying to find A and B. Remember, I know what G and K is. So, if I play with this right, A equal AAT plus AB plus TG plus K. So 0 equal and I must get 0, and that's what makes 0 so unique. 0 equals, so move this to the right. If I look at what's in front of t, it is a times a plus g, and the terms without a t, that is ab plus k minus a. When I say minus a, I'm talking about that a, and that equal to 0. Doesn't that yield that this must be 0 and this must be 0? Now don't lose track of what you know and what you don't know, and I'll show you again. I know what g and k is. I'm trying to find a and b. So here, if I would go ahead and take the first, this says a times a equals negative g. A, I know. A is given. That is 1141. A is what I'm looking for. That's A1, A2 equals negative g. If that is g, isn't negative g 14? Doesn't that say solve that equation? 114114, right? So if I multiply negative 4 row 1 plus row 2 in row 2, what would happen? I'll get 111. Negative 4 plus 4 is 0. Negative 4 plus 1 is negative 3. And negative 4 plus 4 is 0. This is telling me that vector A is actually 0 right there. And if I put a 0 right there, that means, so this is x2 equals, a2 equals 0, and a1 equal 1. I got A. All what I have to do is find B, and I'm home free. And that's really all the work there is. That's the new stuff. So now if I go for the second case, and what's the second case? This case, remember, I'm looking at AB equaling K I know, A I just found. Isn't that right there 1141 multiplied by A1, A2 equaling, and K, isn't K what's in blue right there? Isn't that negative 1, negative 2 plus, and A I just found? Doesn't that make this the vector 1 minus 0, negative 2, if I'm not mistaken? Hopefully I'm not, because otherwise that will take a long time. Let me just double check my work really quick. It will be the bottom. Ooh, negative 8. Good thing I checked. So that makes this a positive and a positive. That will make that a 2 and a positive 2 if I'm not mistaken. Okay, good. You know what? I have my notes. Let me glance at my notes really quick. I'll be right back. Yes, that's correct. So if I'm solving this equation, system of equation, isn't that saying solve 1141, 2, 2? So if I take negative 4 row 1 plus row 2, put the result in row 2. Getting excited there. Wouldn't that be 112? Negative 4 plus 4 is 0. Negative 3, negative 6, negative 4. Doesn't that mean that x2 is 4/3? And if I put 4/3, x1 equal 2 minus 4/3 all over 3, that is 6 2/3. Okay, so B would be 2/3, 4/3. I found A and B, and let me just double check that, make sure that's correct. Okay, good thing I have my notes right there. When I multiply this by negative 4, that's negative 4. Okay, when I multiply this by, when I multiply this by negative 4, that's a negative 4, negative 4, and a negative 8, that's a negative 6. So I'm getting x2 to equal 2, and that means x1 plus 2 equals, so x1 is 0. So again, whatever you get, it doesn't really matter. You're just going to fill it in, and guess what? Now I want to write my solution. I have my A, I have my B. All what I have to do is write it in my final answer. X equals, and that's going to be C1 e to the 3t 2e to the 3t plus C2 negative e to the t and 2e to the t plus a t plus b. And at was, what did I get? I got a to b 1 0 and 0 2. There it is. Now you could combine those. You could say that vector right there is t2 if you wish. It doesn't really matter. But there it is. I see a cosine or a sine. Well, the same deal on number 4. Did I give you a page? Page 542. So if I look at number 4, the same deal. I'm going to figure out the complementary and the particular. I'm going to write out the actual particular. So here I'm going to say, well, the complementary. I'm going to have to figure out the determinant of A minus lambda I to figure out the complementary solution equals 0. Figure out the lambdas, and I'm going to get, out of this, I'm going to get lambda equals 0 and lambda equal 4. With 0, I'm going to have the vector negative 1, 1. And with lambda equal 4, I'm going to get the 1, 1. Again, I'm assuming you could do that. The new part, we're going to look at the particular and say, well, if it's a sine or a cosine, then guess what? We're going to let x equal both a times the sine of t plus b times the cosine of t. And the goal is to find a and b, right? And keep in mind, this f of t, if I write it, that's actually negative 4 cosine of t. And this is how we're going to write it really to figure this out. Negative 4 0 cosine of t plus 0 negative 1 sine of t. And we're going to say, let this be g and let this be k. Alright, for a 2 by 2, it's always 2 of them. So here we're going to say, okay, if you take a derivative of this, wouldn't that be a the cosine of t minus b the sine of t? And now what? Plug him into the original equation. What's the original equation? It's right there. Plug him into that equation. In our case, x prime is going to equal what? Ax plus, just like we did in this problem, it's going to be ax plus t. Whoa, is it? So x prime is going to equal ax plus g times the cosine of t plus k times the sine of t. So when I take a derivative, I'm trying to satisfy this equation. Well, x prime is right there. That would be a the cosine of t minus b the sine of t equaling ax, a, and what's x? We said there's x. That is a the sine of t plus b the cosine of t plus g the cosine of t plus k the sine of t. Do remember that I know what g is. Let me not use that color. I know what g is. What's up, g? And I know what k is. The goal is to find a and b. So now it's nothing more than manipulating this. A the cosine of t minus b the sine of t. And you know from before, those are somewhat the longest. And how does this work? I am gonna get a 0 on one side, everything else on the other side. So I'm gonna get 0 to equal, and I'm really looking at combining the sines and the cosines. So if I write a cosine of t, I write a sine of t, and we know the drill. So the sine will have an a in front of it, plus k, and if I move this to the right, plus b. Oops. Okay, I did that backwards. That's okay. Sine. Let me make sure this, yeah. And if I do a cosine would be AB plus G minus A. And what would that indicate? That would indicate that AA plus K plus B equals 0 and AB plus G minus A equals 0. So here I need to manipulate the problem somewhat and solve. So what I'll do, I would solve one of those. Let's say the bottom. I would say this bottom equation right here, I would say A equal AB plus G. And I would take this right here, and I will throw that right there. And that would be A times AB plus G plus K plus B equals 0. That would be A squared B plus AG. I know both of those. Plus K, I know that as well. Equals, plus B equal 0. So if I get those two together, that's A squared minus IB. You could combine them if you want. Equals negative AG minus K. So if I fill in what I have 2, 2, 2, 2 multiplied by 2, 2, 2, 2, that's A squared, minus lambda 1, 0, 0, 1 I, all multiplied by B, equals negative A, negative 2, negative 2, negative 2, negative 2, times G. G is right there. That is a negative 4, 0, minus K, minus 0, negative 1. So here I'll get 4, 4, 4, 4, right? All of these are 4s, but I subtract minus 1. That would become 4 plus 4, 8. Yeah. That's a plus. That's a plus. So I'll end up with a 9, 8, 8, 9 multiplied by V1, V2 equaling, and what is that mess? That is 8, that's just an 8 right there. And that is an 8, remember that's a 0, 8 plus 1 is a 9. And if I solve this equation, what do I get? I will get B2 equals 0. No, B2. I'll get B2 equal 1 and B1 equals 0. So I got the B. The B vector is actually 0, 1. And now that I know B, I could go back and figure out what A is. That's not going to work. Okay. Now that I know what this is, again, really lengthy, I'm going to say A times B plus G. And what's G? G is negative 4, 0. Equals A. Which means that is what? That is 2 plus 0 plus 2, that's a negative 2, and 2, 0, 2, negative 2, 2. I got 8. So now what? Now I could say my x is, and here they are, e to the 0 is 1, so it's c1 times negative 1, 1, right? Plus c2 times, and you could write 1, 1 e to the 4t, or plug that in, whatever you want. Plus, and we said it's going to be a the sine and b the cosine. A is negative 2, 2 times the sine of t, and 0, 1 the cosine of t. You could combine those if you want into 1. That's the answer. You could combine those and say, hey, that is negative 2 the sine of t. The book does that. Twice sine of t plus cosine of t. That's the same thing. So I want to do an exponential, and then we're done with this. And the rest is just setting up, nothing more. And if I get to number 6, I notice that f of t in this case is really e to the negative 2t times 1, 0 times t plus e to the negative 2t times 0, 3. I'm going to call this g, and I'm going to call this k. Again, you guys, I do know what g is, and I know what k is. And let me restart again. We are going to so if I find the homogeneous, we know how to do that. That is x prime equal ax with nothing else. That is the complementary solution. So that would mean that the determinant of 1 minus lambda, 1, 0, 2 minus lambda equals 0. That would mean lambda equals, so that's 0, that would equal 1 and 2, right? And again, I could show this, if doing it for lambda equal 1, I do my magic and I get my vector to be 1, 0, e to the t, of course. And if I do lambda equal 2 and I do the magic and work things out, I'll get my vector to be negative 1, 1, e to the 2t. So I'm going to push this on the side. Let me see where I can put this. I'm going to take this and I'm going to switch those. So I'm going to put this, shrink it a bit, and put it right there. Again, that's the stuff we've been doing all along. This is the complementary part. Now, if I get this part, I need to see. If I get to the particular part, so again, keep in mind how this works. If I had back in chapter 3, g of t equaling t e to the negative 2t, wouldn't I say the particular solution will be at plus b times e to the negative 2t? I'm going to do the same thing here. I'm going to say, you know what? This particular x is going to be actually at plus b e to the negative 2t. And basically, I'm going to solve. Find a and b, and I'm done. Plug them into there. Now, if you look at the whole picture when you're done, I know it's a lot of calculations and it's kind of annoying, but so what are we going to do now? Now we're going to go to this definition, which says x prime equal, so we're using x prime equal ax plus f of t. And in our case, there's f of t. It's really right there. Oh, I missed one of those. I don't know how that happened. So, to make use of that, I have to take a derivative to really figure this out. Well, what's x prime? Wouldn't that be derivative of the first, the product rule, times the second, plus the first, times, isn't that negative 2 e to the negative 2t? And now, if I plug those in there. So the left side is a e to the negative 2t plus a t plus b times negative 2 e to the negative 2t equaling the right side. A I know. X, isn't this x? At plus b e to the negative 2t plus, can't I take e to the negative 2t and say that is gt plus k? True? Now, do you agree that I could divide by e to the negative 2t and make that disappear out of all of those? The goal, don't lose track, the goal is to find a and b. So, if I really look at this, this says a minus 2at minus 2b equaling aat plus b plus gt plus k. Now what I want to get 0 on one side, everything else on the other side, and I want whatever's with t and whatever's without t. So a plus g. When I move this to the right hand side, isn't that twice a? ab plus k minus a plus 2b. So this tells me that AA plus G plus 2A equal to 0 and AB plus K minus A plus 2B equal to 0. This is like two equations, two unknowns, you know? You remember those from back in the days? So I need to solve those somehow. Well, let's see. If I work this out, if I move G to the other side, that would be A into A plus, no, that's not right. What's common? A is common in both. So if I factor an A out, that would be A plus 2I, if I'm not mistaken, equaling negative G. Well, hey, that's good news. I know how to do that. Why is that? I know A and I know G. I could find A. If I could find A, I'm in good shape. Because if I look at the bottom, if I know what this is, I know what this is, I'll do the same on the bottom. And let me get the bottom ready. The bottom, if I take B out of A plus 2I, that would equal A minus K. If I could find A from the top equation, I'm in a very good shape. So to find A, I would say you get that arrow? That's a long arrow. I'll take A. What's A? A is actually 1102 multiplied plus 2I times A1, A2 equaling negative G. What's G? G is the yellow. That is negative 1, 0. So this is 1 plus 2, that is 3. 1 plus 0 is 1. A 2 and a 4 and a negative 1, 0. Isn't that what that is? I would like to solve this equation if possible. And let me just make sure oh, that's a 0, that's not a 2. Good thing I have my notes handy. So here, if I solve this equation, doesn't that mean that A2 equals 0? And that means 3A1 equal negative 1, which means A1 is negative 1/3 and A2 is 0. This is A. That's half of the problem. Now that I know A, I will go to B. and that's this right here. And I will say a plus 2a. I already did that. That's right there. Isn't that 3104? Right? B1, B2 equals, oh, you know what? Let me write it out. B1, B2 equals A is negative 1/3 0 minus K. And what's K? K is the blue, 0, 3. Which is negative 1/3 3. So basically, I'm solving this system. Well, doesn't this tell me that B2 is 3/4 and 3B1 equal negative 1/3 minus 3/4, which is, oh boy, a lot of fun, which is over 12, negative 4 minus 9. Negative 4 minus 9, let me think. Yeah, that's right, that's a minus, Making sure. I'm getting something different slightly. Let me just... Oh, okay, that's a negative 3. There we go. That's much better. That's a negative. That makes that a positive. That will make this 4 minus... That's a 5. And if you divide by 3, that means B1 equal 5 over 36. And doesn't that mean that B is 5 over 36 and negative 3/4? There, I got B as well. There's A, there is B. What is my general solution? My general solution will be x equal, and the part that I kind of squished out, that is 1 C1 10 e to the t plus C2 negative 1 e to the 2t plus, and it's right there. I lost it. I had it. Oh, it's right there. Plus at plus b plus a t plus b times e, what did we say, negative 2t. I am going to take it a step further. The author likes to write those as C1 e to the t0 plus C2 negative e to the t2 e to the 2t plus, and they combine those. Just like back in chapter 3, we wrote C1, C2, but for the particular we always found those. It'll say negative t over 3 plus 5 over 36 and negative 3/4. You don't have to. This is fine. Now, on the next problem, they don't want us to work it out. They just want us to list. Can you just list what the actual equation would look like? Now, of course, here I forgot to mention, if x of 0 is given, then we can find C1, C2. And you could tell, as it is, how long the problem is and how much longer it would be. 8, they just want us to write the equation of how that look like. The way this works, I would write this as t squared 0 plus 0t plus 0. I would separate between those. I would separate between the t squared, the t, and the constant. I will call this G. I will call this K, and call this H. And here I would say, so again, what they want, only the form of the general. Use the method of undetermined coefficients to determine only the form of the particular solution. Only the particular, though. X prime is going to equal AX plus the particular part is going to be what? So this is GT squared plus KT plus H. I do want to point out, if you only had the square, if you only had T squared by itself, or T squared and the 1 or T squared and the 2, you're still going to say that the particular solution is the general for T squared, which is AT plus BT plus C. That would be the general form of the particular, and I don't need to tell you how much fun that's going to be. And on number 10, the same deal. I want to work this out. This is, again, just writing the form. And again, those are kind of long. X is going to be AX plus, and let's see what this is. Wouldn't you say this is T0 e to the negative t plus 0.3 times e to the negative t? Do we see that? If I call this G and I call this, I'll be calling H, right? K, I'll be calling it K. I should call them HK, right? My initials. Yeah, next time I teach the class. So, in what we have, this is GT e to the negative t plus K e to the negative t. And do you notice what's going on here? The particular solution is going to be what? Well, it's going to be AT e to the negative t plus B e to the negative t. And in case you're missing out what I'm writing, that's really AT plus B e to the negative t, which is what we did before. If I told you that we have a y double prime plus y prime plus 3y equal t e to the negative t, wouldn't you say the particular is AT plus B e to the negative t? The general? So we're doing the same thing. Nothing new. I do want to set up one more problem for you. I just wanted to point out for number 5 and 9, you notice what the function look like, f of t. So when you take f of t and you decompose it, you say this is 1, 0, 0 e to the 2t plus 0, 1, 0 times the sine of t plus 0, 0, 1 times t. Call this G, call this K, call this H. I do want to point out, you do this individually. That is simply A e to the 2t. Do the work by itself when you're done. Remember how we did that? For sine, you would let f of t equal A sine of t plus B cosine of t. And for you let f of t equal the general for t, which is AT plus B. So you could do this individually, work it out, this individually, work it out, this individually, work it out, and sum of the answers just like we did back in section, I forgot what was it. Was it 3.5, 4.5? Let me see. 4.5, superposition. If you recall, when we did those, like here, do you remember we did by itself, we worked it out. The sine square, we wrote that as sine plus cosine. Actually, we worked it out. No, not here. Here, I'm sorry. We worked it out in those. Do you remember when we did those? So if we had a combination of those, say we had Oh, here we didn't work him out. Superposition, where was that? I thought it was for 5. Yeah, superposition. If you have, oh, here we go. If you're dealing with t, then you do at squared plus bt plus, you do that by itself. You do e to the t by itself, and you do e to the tt by itself, and you sum those up. I remember doing problems like that. I just can't remember where. Oh, number 28. There we go. So if you recall, we did actually e to the 2t by itself. It's right, e to the t, and then we did e to the 2t by itself and the constant by itself, and we summed up the solutions. So, I know it's been a while. There's the homework.